Okay, we're now going to turn our attention to the development of the ventricular septum. And again, we will start with a very simplified diagram. And then after we understand how it normally happens, we'll take a look at some diagrams from the notes. So on this diagram, this would represent the part of the heart tube that enlarges and becomes the ventricle. And this would be the outflow from the ventricle, what we call the truncus arteriosus. And so again, our objective is to divide the ventricle into two ventricles by building a septum down the middle. And just as we talked about before, dividing the ventricle into two doesn't make any sense unless we're also going to divide the outflow into two outflows. So we're going to have to divide the truncus arteriosus into two, and we'll build a septum there to accomplish that. So again, we'll be using two septa, but instead of the two septa being side by side like they were in the atrium, they're going to be end to end. So let's get started. The first septum will develop within the ventricle itself. Now, how this develops is not really that important. The only thing that's important is to appreciate the fact that it actually develops from the ventricular wall itself. So it develops something like, let's label this first, ventricle, truncus arteriosus. So here's the septum that develops from the ventricular wall itself, and we're going to call that the embryonic ventricular septum. So 2 points. One is, you notice that it is an incomplete septum. It's an incomplete septum. So it's only partially dividing right from left ventricle. And the other point is, since it develops from the ventricular wall itself, it's made of the same material as the ventricular wall. In other words, it's made of cardiac muscle, just like the ventricular wall is cardiac muscle. Okay? So that's the first point. Now, let's go and talk about the other septum that's going to divide the truncus arteriosus into two. So when we divide the truncus arteriosus into two, we'll end up with two outflow vessels. And we want the septum that divides this to be exactly in the middle of the truncus, so that we're dividing it exactly in half, so that the two vessels will be exactly the same size. So once we accomplish that, the two will have a septum right down the center like that. We'll talk about where that comes from in just a moment. We'll have a septum right down the center, and the two vessels that we've thereby created, one will be the aorta, or more precisely the ascending aorta, and the other would be the pulmonary trunk. And so the name of this septum that divides truncus arteriosus into aorta and pulmonary trunk, the name that we use for that is the aorticopulmonary septum. That's what creates an aorta and a pulmonary trunk out of the truncus arteriosus. Okay? So where does that come from? Well, it develops in a way that is similar to what we said about the endocardial cushion. There are cells from the wall of the heart tube, the part of the heart tube that is the truncus arteriosus. There are cells that invaginate and meet to form the septum. And again, those cells that invaginate from the wall were not originally part of the heart tube. They migrated to the heart tube. They were also neural crest. So again, the aorticopulmonary septum is a neural crest-derived structure. Okay? And it's very important to note that normally it forms exactly in the center of the truncus arteriosus, so that the diameter of the aorta and the diameter of the pulmonary trunk are equal. And we want that, of course, because the outflow, the cardiac output, the outflow from the two ventricles are the same. So we would like the vessels into which those outflows go to be of the same diameter, which they are. Now, that aorticopulmonary septum, when we get down into the ventricle, it doesn't suddenly stop. It keeps on going. and all the way down. And since that septum is right in the center, and because the embryonic ventricular septum is right in the center, they end up meeting end to end like that and fusing, thereby completing the ventricular septum. So in the adult, we have a ventricular septum that has two different origins, and they have two different compositions. We end up with a part of the ventricular septum being called the muscular interventricular septum because it contains cardiac muscle, and that's the part that developed from the embryonic ventricular septum. And then we have the part that we call the membranous interventricular septum because it has no cardiac muscle in it, and that's the part that develops from the continuation of the aortical pulmonary septum. So they together form the complete interventricular septum. And so once we've accomplished that, we've now finished the formation of the septum, and we have a left ventricle that's flowing into the ascending aorta and a right ventricle that's flowing into the pulmonary trunk, which is exactly what we want.